Okay, so let's look at the optimization. So it says here that you can make this more efficient if you realize that the numerator of each term is really the same as its predecessor multiplied by x. So, because notice here, x squared is just the previous x times another x. X cubed, the previous times another x. And so what we're going to try to do here is we're going to try to, and then for the denominator, we're just multiplying the previous one by another value. So we're going to try to see if we can make those changes. So what we're going to need is a couple of other, let's make next numerator, well, actually, let's do this. So it will start with our first numerator, and we'll leave them as int. We're going to say that our numerator, our first numerator, is going to just be 1. And then our first denominator is also going to be 1. And what we're going to do here, what they say here, is the next numerator is always going to be the previous numerator, and the previous numerator was n, just times x again. So instead of recalculating the whole thing, we'll just take the previous one and multiply an x to it. And actually, let me just take that out for a second. And what I'm going to do here, before we even go further, is we're going to call this faster my exponent. And I'll camel case it. And what we're going to do here is let's get rid of that. Let's get this back to where it was before. And let me compile and run this again. Denominator. What is my error? And that'll be an intermediate form. Okay, so this still works, but I'll leave it here for a reference, and I'll do that not infrequently. I'll make copies like this. So we have our numerator and our denominator. Now our next numerator is going to be the previous numerator times x, and our next denominator is going to be our previous denominator, and we just have to multiply in the next value of I. And so then we have our term. Everything should be all right. And what we're going to do here is let's make fast result, and we'll say fast result equals my exponent of, or this will be fast my exponent, and then we'll just display fast result. And I forget how all of this, oh, well, I've misspelled result. Maybe I just put a string in here. We'll just do a printf. It's been a while for this. So that'll be float result, and fast result. Cannot find fast my exponent. Let's see what I called it up here. Faster my exponent. Because it's not necessarily so fast, we don't know, but it is faster. And we got to put in our new line before we even check anything. And we've got an infinity in here, so that's a little bit of a problem. So let's see what we got here. Let's figure this one out. So if our numerator is I, and I is 0, well, first off, we're going to have to start multiplying this by 1. We have to start 1 into this, which means we're not going to be able to, so here we'll have to put a special case. If n equals 0, will just return 1. Because the first time through, if we start I at 0, as soon as we multiply our denominator by I, that becomes 0, and then everything, multiplies will always be 0. You can't divide by 0. That gives us our error, our infinity. But we know that the 0th term here is just going to be 1. So let's see what this gives us now. And let's see. So doesn't look quite right. So we got a little error here. So when I is 1, are we going to be 1 off? Let's print out, let's think about this. So when I is 1, I think we want to multiply that by I. Sorry. I think we're going to be, you see, this is a mistake that I'm making. What I'm doing is, rather than working it out, I'm trying these one-off errors. But let's figure this out. So let's go back to printing out in here each time. And what we're going to do here is we're going to comment all of this out. So that way it doesn't run, and what we'll just do is we'll take this single line here, and we're just going to say, well, let's just result equals my exponent 1i of what's 5, and fast result equals my, or faster, my exponent 1.5. And again, I'm not going to get any more information yet, but I am going to make sure that works. And now let's see what we're actually doing in here. Let's debug this. So here we've got, where are we? Okay, we got our double, our results. That's fine. Let's print out in here, and again, not in there, but rather in here. We're starting out, our numerator is going to be 1 and our denominator is going to be 1, and that's true for our first case. And then that's going to be our 1 term, so 1 over 1 is 1. Our result has to start at 1 because otherwise we're going to be 1 off. If we started at 0, this used to return it okay, but then it's going to add, we're not adding in that first term. So actually, I'm pretty convinced that this is going to work, and there was no real error, and that looks good. So I'm going to come back down to here. Let's comment that back in. Let's get rid of these lines. And there we have it. Both routines work. So it really wasn't that bad to do this conversion. Now, some of you might have been tempted to say, let me do, well, there are a few things you might have been tempted to do. One is when you're originally inviting this routine, you might have been tempted to figure out this power, the x to the n or x to the I, right inside here, either by putting another for loop or doing it, using the calculation. And that's just like, you don't have to have your brain work that hard. All right. Just like, oh, I need to do power. That's going to be a couple lines of code. Let me factor that out into a separate routine that I can test it. And I think that makes this a lot easier. The other thing that you can do is, notice in faster exponent, you might say to yourself, oh, look, I see this relationship. I can do this right away. But this is a little bit more complex to get your brain around all at once, and it really requires you to think it through. And really, the fanciest program, the most efficient program, the slickest program, doesn't do anyone any good if it doesn't work. So like, I always think, like, the first thing you want to do is write a simple, working, maintainable version that you can understand, that everyone can understand. Then you can make it better. And once we wrote this version, this slower version, this faster version didn't take too much work, but we already had a working version to fall back on. And in reality, this was an exercise. But if this were real life, this simpler version would probably have been fast enough, and so why bother making it more efficient? You know, make it clean and understandable first and foremost. Okay, so that's really this problem. And you know, I don't like doing a lot of these. I think they're a little math centric, and I think there's such a richness of problems that you can explore. You know, some of which will be mathy, but a lot of them won't be. There'll be language processing, there'll be graphicsy, there'll be, you know, all sorts of other stuff. But I think there is a lot of richness in how you can approach this problem, and I hope these couple of videos helped.